Hello students, in our last class we had seen the modeling of the string, that the string is light and inextensible. When we say that the string is light, that means its own weight is neglected and an uniform tension is developed in the string. And inextensible means its length does not change. So both the connected particles will accelerate at the same rate. And when the pulley is modeled as a smooth and small pulley, that means no work is done against the friction and hence the tension remains the same. The tension does not change on particles P and Q. So let us see one other type of problem here. So let us first read this problem carefully. Now here, two particles P and Q of masses 3 kg and 5 kg are connected by a light inextensible string which passes over a small smooth pulley. Initially both the particles are held at rest 1 meter above the ground and released. Q reaches the ground and does not rebound. Find the maximum height reached by P above the ground. So let us first draw the diagram for this situation. So I'll just introduce this diagram here. Okay, so these are the two particles which are connected by the light inextensible string which passes over a smooth and small pulley. Now one particle is of mass 3 kg and another particle is of mass 5 kg. So this is particle P here and this is particle Q here. Now, initially both the particles are held at rest 1 meter above the ground. So, suppose this is the ground level. So, both the particles are at a height of 1 meter above the ground. And from rest they are released. So, which are the forces which will act on particle P? First of all, its weight 3g acting down, and on 5 kg, that is particle Q, weight 5g acting down. So the tension T, because the string is light, uniform tension will be developed in both arms of the string and equivalent opposite tension from pulley towards the particle. These are the forces we are going to show here. Now, since the particles are released from rest and the weight of 5 kg is larger, the acceleration of this mass will be downwards and the string is inextensible, so particle P will accelerate at the same rate upwards. Now, first let us find out the acceleration of these particles. So, for P, what will be the equation of motion? For P, since the resultant force is acting upwards for P, because P is accelerating upwards. So T minus 3g that is the resultant force, and that is equal to by Newton's second law 3a. Similarly, on particle Q, now particle Q is accelerating down, so phi g minus t is equal to phi a. So you'll add and solve these two equations so that t and t will get cancelled. So phi g minus 3g is 2g, and that is equal to 8a. So the acceleration of the particle is 2g upon 8, that is g upon 4 meter per second square. So both these particles, now since the string is inextensible, both the particles will accelerate at the same rate of g upon 4 meter per second square. Okay, now this particle Q is traveling 1 meter down and coming to the ground, and it does not rebound. So let us see this situation. Let us draw the diagram. So this is particle Q here. This comes to the ground by traveling 1 meter downwards. At the same time, particle P, which is held at the same position of 1 meter above the ground, so now keep it in mind that since the string is inextensible, both the particles have same acceleration and both the particles are released from rest, that is initial velocity is 0, and hence both the particles will have same displacement and same final velocity. That means when this particle will travel, that is particle Q, will travel 1 meter down, particle P will travel 1 meter up, because the displacement of both the particles will be the same. So this is particle P here. So when the particle Q has traveled 1 meter down, particle P has traveled 1 meter up. So the question is, as soon as this particle Q reaches the ground and particle P comes to a position, say x here, 1 meter above the initial point, will it stop immediately? The answer is no. Why? Because as soon as this particle Q reaches the ground, the string will become slack. String will become slack. So these two words, keep them in mind. When I say the string is slack, that means no tension in the string. No tension in the string, and when the string is taut, the string has tension in it. So these two terms, just keep them in mind. When the string is slack, that means there is no tension in the string. String is taut means there is a tension in the string. So when the particle P comes 1 meter above the initial point to a point X, the string will become slack because particle Q has touched the ground. That means here for particle P, the upward force will be 0 newtons because now there is no tension in the string. The downward force on the particle P is 3g, but keep it in mind that the particle is still traveling upwards. The resultant force is still up. So what will be the resultant force on this particle P? 0 for particle P. The resultant force F will be 0 minus 3g. Keep it in mind that even 3g is greater than 0, the resultant force is not downwards because still the particle is traveling upwards. So resultant force is in the upward direction. So this will be equal to 3a, or that gives a is equal to negative g, which will mean after x, the particle will decelerate in gravity due to gravity at a rate of 9.8 meter per second square, and then after traveling a small distance upwards, it will come to rest at some point y here. So say here, after traveling a short distance, it will come to rest at point y. So it will travel an extra distance of xy, and that you have to find out now. Again, keep it in mind that because the acceleration of both the particles is the same and both the particles are released from rest, whatever will be the final velocity of the particle when it touches the ground, with the same velocity, the particle P will come to point X. So first let us find out the final velocity. Final velocity of particle Q. Now for particle Q, it is released from rest. That means the initial velocity is 0. U is equal to 0. A is g upon 4 for the journey from point of release to the ground. The acceleration is g upon 4 meter per second square. The displacement of particle Q is 1 meter. So let us use the SUVAT equation. Why do I use SUVAT equations? Because the acceleration is constant. That is the main condition to use SUVAT equations. So V square is equal to u square plus 2as. Now u is 0, so we get v square is equal to 2 into g upon 4 into 1. So that is v square is g upon 2 and v is equal to root of g upon 2, which is 2.21 meter per second. That means this particle q will touch the ground with a speed of 2.21 meter per second, and because the acceleration is same and both the particles are released from rest, when the particle p comes to point x, its speed will be the same. So particle p comes to point x. With the speed of 2.21 meter per second. That means for the journey from x to y, we can take the initial velocity u as 2.21 meter per second, and then as we had discussed here, after point x, the string is becoming slack, so the particle will decelerate only due to gravity. That means after point x, the acceleration of the particle will be negative g, that is negative 9.8 meter per second square. So let us see this journey of particle p from x to y. Particle p from x to y. Now at x, the speed of the particle p will be same as the final speed of particle q when it reaches the ground. So u will be 2.21 meter per second. Then a is negative g because it will decelerate in gravity. So a is negative 9.8 meter per second square. And since the particle will become stationary when it will reach the point y, so at point y here, this is y here, so the speed of the particle will be 0 meter per second because at this point the particle will become stationary. So v is equal to 0. I want to find out the displacement. So use v square is equal to u square plus 2as, that is 2.21 the whole square plus 2 into negative 9.8 into s, and v square will be 0. So that means s will be 2.21 the whole square upon 2 into 9.8, which comes out to be about 0.25 meter. So the particle P will travel an extra distance of 2.5 meter from this point X to the point Y. So this distance from X to point Y so this extra distance from point X to point Y will be 2.25 meters. So keep this concept, try to understand this concept here, because the string is light and inextensible. The acceleration of both the particles is the same. Both the particles are released from 1 meter above the ground. Since Q's weight is higher, it will accelerate down, and because the string is taut, uniform tension, P will accelerate up. So when Q will travel 1 meter down, P will travel 1 meter up and come to the point X. Now, since the acceleration of both the particles is the same, with whatever velocity the particle Q will reach the ground. So here the final velocity of particle Q is 2.21 meter per second. So with same velocity, particle P will come to the point X 1 meter above the point of release, but the particle P will not stop immediately. After that, the string will become slack, and the string will be slack means there is no tension in the string. That means the resultant force on particle P will be 0 minus 3g. Still the particle is accelerating upwards, which is equal to 3a by Newton's second law. That means after the point X, the particle will just decelerate in gravity. So it will decelerate at a rate of 9.8 meter per second square, and it will travel an extra distance from X to Y and then stop. So for this journey from X to Y, the initial velocity you will take it as 2.21 meter per second. Final velocity here will be 0, and acceleration of the particle is negative g, because now it is accelerating at a rate of negative g. That means it is decelerating in the gravity at a rate of 9.8 meter per second square, and hence it will travel an extra distance of 0.25 meter from X to Y. So total distance traveled by P above the ground before it comes to rest. So first it is released from 1 meter above the ground. Then when particle Q traveled 1 meter downwards to reach ground, particle P again travel 1 meter upwards to point X, and then from point X to point Y, it has traveled an extra distance of 0.25 meter. So total distance the particle P has traveled above the ground before it came to rest is 2.25 meter. Which this concept is okay with you? I'm giving you a very similar problem to try at home. So just try this problem on a very similar lines because it is just the same type of problem here. So just go through these concepts and any doubts, make them clear in the next class. See you students. Enjoy the day ahead.